Guy McPherson here. Thanks for joining me and Neil Shepard for our foray into CO2 and beyond, other greenhouse gases, emissions, and pollutants accelerating climate change. And by accelerating, we mean things are already out of control and they're getting worse. I'd like to start this particular episode with a dedication, my first dedication to somebody who is still living. And I asked him for an overview, and Dr. David B. Wester wrote, in terms of a curriculum vitae, or literally course of life, here's how he begins. He grew up in Denver, Colorado. He completed his undergraduate work at Colorado State University, graduated in 1976 with a BS, a Bachelor of Science, in Range Forest Management. He went on to Texas Tech University in 1976 to pursue a master's degree with Dr. Bill Dahl, and he stayed there and stayed with Bill Dahl for a PhD. Got his master's in 1979 and his PhD in 1984. He joined the faculty at that same department at Texas Tech University in 1983, the academic year before he graduated with his PhD, and he remained on that faculty until 2011 when he moved to Texas A&M University Kingsville and the Caesar Kleberg Wildlife Research Institute. There, he was a professor and research scientist. He was the inaugural person to hold the Francis and Peter Swenson Endowed Chair in Rangeland and Restoration Research. He held this position from 2021 until 2023 when he retired. He is now Professor Emeritus of Rangeland and Wildlife Sciences, and he currently lives in College Station, Texas. And he writes that because of the generosity of too many people to be named who have been thoughtful enough to include him as a collaborator, Professor Wester had an opportunity to publish his first refereed paper as an undergraduate student with his advisor, Dr. M.J. Trelisa. He was able to teach his first graduate course in 1979 when he himself was a graduate student. And over the course of his career, he has written or co-written 200 refereed journal articles, peer-reviewed journal articles, 8 book chapters, more than 360 scientific presentations. And he's been associated with a $6.5 million grant in sponsored research. He taught courses at the undergraduate level in range, forest, and wetland plant identification, range ecology, and at the graduate level in experimental design and analysis, applied regression analysis, applied multivariate analysis, and practical non-parametric analyses, and synecology. And this is how I knew Professor Wester best, is because I was at Texas Tech University as a graduate student, and I was taking his courses in experimental design and analysis. And he was an amazing teacher. It's a sad day that we no longer have him in the teacher's role at a major university. With that, I will turn things over to Neil, and you can get us started with a beautiful presentation that you have designed.
Thanks, Guy, and that was a great dedication. I'm hoping to be able to get some a photo and other things to add in here. You know, today I would like to start by sharing a video that will take us into the origins of understanding greenhouse gases, particularly CO2. We're going to spend only a little bit of time on CO2 because the history of that is well known to people. We're going to then move to a discussion of other greenhouse gases. In this segment, probably only we will get to methane, but that will be something we do in future sessions. So I'm going to try and share an interesting video I came across.
In 1856, a scientist named Eunice Foote conducted an experiment. She filled one tube with regular air and another with carbon dioxide, put thermometers in them, and placed them in the sun. And she noticed the tube of carbon dioxide got a lot hotter and stayed hot longer. She published her results, noting that an atmosphere of that gas would give to our Earth a high temperature. 3 years later, Edwin Drake struck oil in western Pennsylvania.
I'm pausing here because what we've just seen is an early scientist, Elizabeth Foote, who did a very simple and elegant experiment that proved incontrovertibly that the exact same quantity of gas the exact same thermometer, put in the exact same heating of the sun. If the air inside around the thermometer was normal air, it heated up a little. If the air inside had a higher concentration of just one gas, CO2, it heated up massively. Can you think of any more elegant and incontrovertible experiment? Air with CO2 is a greenhouse effect.
Right. That's beautiful. It's stunning in its simplicity and yet so straightforward.
And ironically, it happened just 2 or 3 years before the first oil well in North America in Titusville, Edwin Drake's well, which we've covered in several episodes back, the birth of the modern oil industry in this country and arguably in the world.
So you're saying it's her fault?
I think it is true that if you name a problem, you often get blamed for it, even if you're raising the alarm.
Right.
But let's keep going, because there's a little more irony here. It'll bring us right up from 1850s to the year of our birth, almost.
100 years after that first well, the American oil industry celebrated its centennial. And they invited the physicist Edward Teller, one of the inventors of the atomic bomb, to make a speech about the future of energy. We probably have to look for additional fuel supplies, he told the crowd, because the extra carbon emitted from burning fossil fuels causes a greenhouse effect, which he believed would be sufficient to melt the ice cap and submerge New York.
So I'm pausing it again because I find it interesting on 3 levels here. They invited a physicist who was one of the 2 physicists arguably most responsible, nuclear bombs, atomic bombs that we dropped on Japan and ended World War II. Obviously a smart guy. He's invited to the centennial of the American Petroleum Institute to give a speech. And of course he says, well, you are going to have to find a different fuel because releasing all this carbon will heat the atmosphere enough to submerge New York. And nobody would want that, right? This speech he gives is 1 year before you and I are born on this very strange world. What are your thoughts on that irony?
It's all about the money. Again, I've said it probably 1,000 times on air that, they knew. They knew this was going to literally destroy the world that they inhabited, that it would cause the polar ice caps to melt, that it would cause New York City to be flooded, and so on. They knew all this. But for a few dollars more, carry on.
And Edward Teller, was he a liberal? Was he a softie? Or was he a fervent anti-communist who actually, we think, implicated his colleague, or J. Robert Oppenheimer, just because he was a little bit from a liberal socialist background. His parents were socialists. So we're not dealing, am I correct, Guy, from your knowledge of Edward Teller, we're not dealing with some snowflake-hearted liberal who is just worried about the big-eyed polar bears. Am I right?
Oh, yeah, absolutely.
I think he was a fervent anti-communist and ratted other scientists out to J. Edgar Hoover. I could be wrong. I don't want to slander the man's name and his family. So if I'm wrong, I take it back. But that's what I seem to remember.
But the science here couldn't be more straightforward.
Indeed.
Right. The evidence that has been presented now, more than 100 years ago, and then many times more recently, it's clear.
So we're just going to see where they take this, another minute or two of this.
By 1965, scientists were confident enough to formally warn a U.S. president, Lyndon B. Johnson.
A decade later, Exxon's own scientists were making grim predictions. By 1988, it was front-page news. And since then, we've kept pumping carbon dioxide into the atmosphere at an accelerating rate.
We have a world economy today that depends on fossil fuels for most of its energy.
A third of it from oil.
It's a tremendous irony that the very substances that helped us achieve this level of development today are now the very substances that endanger the future of civilization as we know it.
So I think that's all we need of this. What are your thoughts, Guy, just on where those two speakers took us.
My most recent interview with the final
Final countdown. Yeah.
which was conducted on the 1st of October, 2024, we talked about a little bit of this. And, these are media personalities who I was talking to, Steve Gill and Ted Rall. Ted Rall, a cartoonist, and they knew exactly everything that we've talked about so far. And, they're covering dozens of stories every day, 5 days a week with their 2-hour radio show. And they know this stuff.
Good.
Like it's a big surprise to them or a lot of other people that the Earth is displaying considerable imbalance in terms of energy, too much heating going on. And, it's not like we only discovered this yesterday.
Indeed. And so with that, let's turn briefly to the history of CO2 measurements since 1958. So again, I'm putting the pin in certain timelines just because, Guy, as you and I get into our 60s here, I mean, reflecting back, there's people listening who probably are older than us, so they were born, I guess, in the 50s or even in the 40s. They were still just teenagers or young adults when this information began to come out. Once you start seeing this information, how do you react if you're a sensible person? I just look at this curve and I see almost just the history of our own lives, because the scientific measurement in our atmosphere began in 1958, 1 year before Teller's speech to the American Petroleum Institute. And by 1970s, first oil crisis, you and I were 13, a little wet behind the ears. And then we went to university, or fortunate enough to go to get a college education. But right in the midst of that college education, the late 70s, early 80s, ice core analysis in Greenland and Antarctica by multiple scientists, multiple different countries and their scientific disciplines, all confirms the drilling and analysis of gases trapped in ice cores adds 800,000 years of incontrovertible proof that measured CO2 increases are dramatic, are from human activities, are abrupt by any geological standard, and are triggering abrupt climate change.
And this was 1980, 20 years after you and I were born.
Indeed. And, the scientists then you realize by the 80s, the scientists weren't just pointing at one measurement station on top of a dormant volcano on Mauna Loa. That had been operating by 1980 for 22 years. It would take any normal scientist who just knew Elizabeth Foote's work and the work of, I think there's 4 or 5 other scientists that you cite frequently that are pre-oil age scientists who knew this. But I don't need anything more, Guy. From my high school biology class in a major American city from the 70s, I had a biology teacher who had us read The Limits to Growth, and our biology textbook was called Ecology, Man's Place in the Biosphere. And ecology was a concept in the 1970s because people were aware of this. And I just need the scientific, to find out that the air we breathe is changing as fast as just the data in this chart. If I'm moving the arrow from just 1958 to 1970s, that's 15, 20 years of data that shows that our atmospheric gases are not stable. They're increasing at quite a high mathematical slope, which is already starting to curve upwards, which means it's somewhat exponential. Guy, obviously you and I are 15, but as a scientist now, what does that data say to you? Just the first 15 years of it.
Well, it indicates an exponential change, obviously, something with which we as humans are poorly equipped to deal with, because throughout the history of natural selection, evolution by natural selection, we've never had such a thing happen. The years in the near future are a lot like the years in the near past. So this is something with which we as human animals are poorly designed to deal with, and I use designed in quotes, obviously.
Right.
But still, it's pretty obvious. And also you can see here the seasonal effect. Most of the land mass is in the northern hemisphere. And so when the northern hemisphere is photosynthesizing, it's taking up carbon. And that's why this thing isn't a nice solid line. Instead, it has the ups and downs associated with every season. So in every year of this thing from 1958 to 2024, whatever it is, you can see that there are peaks in carbon dioxide. That's because carbon dioxide is being off-gassed, being respired from the plants in the northern hemisphere. And then they go down, they dip down every year by approximately the same amount as a result of carbon dioxide being taken up through photosynthesis, largely in the northern hemisphere.
Two climate scientists, paleontologists, paleo climate scientists in the 60s, 70s, and 80s who were paying attention to this. This must have sensitized them to look in their own work, the fledgling paleoclimatology field of looking at proxies, looking at things other than ice cores even, had begun. It was just in its earliest stages, am I correct, where they find 50 million year old strata, and they look at the leaves and the pores in the leaves and 15 other different types of fossils, and they can start to now measure, how sudden were changes in the past in atmospheric gases, in oxygen and CO2 and all the atmospheric gases and trace elements, and what does the research say about temperature? And that's in addition to the ice core analysis. And we've gone over this in our early episode. We went into some depth in this, but I just want to stress the drama of our own lives, that we were just in our 20s when this second correlative, this second body of completely independent scientific data, that is ice core analysis, completely independent from atmospheric measurements at Mauna Loa, gave us atmospheric data, atmospheric gas data going back as much as 800,000 years. And that data told us what we could already see, that there is a fantastically abrupt change afoot, and that this change is traced to really begin with the coal age. If you look at the curve, and we looked at it in other things, and we'll have a chance to look at it again, it really starts to pick up around 1700, 1705 with the use of coal at scale in Europe and in North America. This is where we are.
Right. And there's no going back. Nobody has ever caused that line, jagged as it is, to go backward in time.
It's pretty remarkable.
That's all we need to do.
I think
right?
that if you actually look at this line, there is the very slightest softening right starting in, I don't know if it correlates, but it goes up, and then there's this little softening where my arrow is. That's maybe that is just the brief period of conservation inaugurated under President Carter, you see, because he did try. He's the only president. Nixon started it only because of wars, the oil in the Middle East and the oil embargoes. President Carter understood energy. He was a nuclear scientist aboard a submarine. He was trained as a nuclear physicist, as every submarine captain is. And he implemented a whole bunch of conservation things that we all had to observe as teenagers, and our parents, mostly people's parents kind of pitched in and tried to insulate their homes and turn the thermostat down to 68. And there's a tiny softening of it. It flattens out a slight bit and then it rockets up, because who's that guy who's elected in 1980? I forget his name.
You mean Ronald Reagan?
Yeah.
That was a world changer.
It's been party like it's 1999 ever since. So let's look at methane, because this is just the first of the greenhouse gases. So whoops, it turns out that, of course, having measured CO2, guess what? We had the brains to start actually measuring methane in the atmosphere in 1984. So kudos to us. We got a clue and said, maybe we should measure the other known greenhouse gases. And guess what methane has been doing since we began measuring it? It's been
Well,
rocketing up.
of course it has. Notice the slight leveling there in the late 1990s through the mid 2000s, through about maybe 95 through 2005.
What should we make of that?
Well, I don't know, although I've seen this reported in many places. I've never seen anybody give a cause.
It could be that the oil exploration had tapered off, and oil exploration and fracking and other things get started in the 2010s and rocket up under first Obama and then have just continued. We can look into that in future episodes.
Right.
But let's look further into methane. So all of this is from either the International Energy Agency or one of the other agencies that tracks this stuff.
The other renowned one is the Energy Information Administration of the United States.
Right. Either EIA or IEA.
Right, exactly.
Quiz at the end. And there's 19 other ones. So look at this. In this chart, wetlands. So this is called natural sources of methane. And it's important, am I right, Guy, to know that even before humans, methane is a gas that is released periodically in the cycles of growth and decay of all plant matter and life, and in the digestion of many animals, from insects to ruminants. Am I correct?
Yes, absolutely.
And there are certain insects, am I right, that produce quite a bit of methane for their size. I
Yes.
don't remember which ones those are.
Yes, and if you talk with climate deniers, they are the ones responsible for the warming of the planet.
Ants. I think ants and termites are fabulous methane producers.
Yes, I know termites for sure are, and so we can blame them instead of ourselves.
But it's one thing to realize that whatever the natural sources are, until humans began adding to them, those natural sources we know from at least the last 800,000 years were not nearly as abrupt as what we have done since 1700. And while they have played a role in the climate, they haven't played recently. By recent, I mean 800,000 years. They haven't played as abrupt a role as just what we've added. Is that fair to say?
Right, absolutely. Yes. I mean, there's all kinds of greenhouse gases. I think there are 31 that have been identified. And most people know quite a bit about carbon dioxide because that's the one that humans contribute the most to. But we also contribute greatly to methane through a variety of sources. And there's a lot of other stuff going on out there. The most abundant greenhouse gas is water vapor. And we have very little control over that as individuals or as a society, obviously.
True. I'm looking at this chart and I need to go back to it because it's already representing things in a strange way. It's mislabeled, and this is not me mislabeling it. We have agriculture here, which they've labeled anthropogenic, as if only agriculture is anthropogenic. The energy sector, the oil industry, the natural gas, coal, and whatever the green thing is, I think that's bioenergy. So burning biomass produces methane, duh. And waste of all kinds, composting, decaying matter, both industrial waste and farm waste and so forth, and then other. And then the burning of biomass down at the bottom is a separate category from bioenergy. It's all, everything below natural here is anthropogenic. So there's a little funny labeling here in the chart.
Well, of course.
And the natural methane, the other thing, Guy, that we should be sensitive to, and that I don't think anyone is adequately measuring, but there may be a few scientists that are, it's very hard to measure what I'm about to say. If we were not here, if humans were not here with all these anthropogenic ones, they're all of this, from agriculture down to biomass burning, is all anthropogenic. There would always be a natural cycle of methane released and other greenhouse gases, but we're talking about methane from, and they call it wetlands, but from the entire natural world. And now with all of these anthropogenic additions, and heating, isn't it the case that this heating is triggering further releases of what is going to be labeled as natural sources? That would mean permafrost that's melting because of our activity is releasing ancient methane. It was always releasing a little ancient methane every season, but now it's releasing more because the melting is accelerating. And we're going to have a tough time deciding what part of atmospheric methane is from us and what part is from ordinary natural sources and what part is from natural releases that have accelerated or tipped, to use this is where the tipping point comes in. We have tipped natural sinks into accelerative release. Am I correct in how I'm seeing this?
Yes, and that's why we call these self-reinforcing feedback loops, because they are self-reinforcing. Once we start rolling these big snowball down the hill, it gets bigger and bigger, and it's out of human hands at this point. They are self-reinforcing feedback loops. It's the processes themselves that are driving the thing now. Humans have very little to do with certain emissions at this point, even though, you know, we just keep charging along, emitting carbon at every opportunity. Still, there are many sources of carbon and other greenhouse gases that
Indeed.
are beyond our control at this point.
And if we've tipped methane, I mean, we could wind down, theoretically, we could wave a magic wand and wind down our use of oil, natural gas, and coal. We'd obviously completely cease industrial civilization. And there's certain climate scientists and pundits who say, oh, well, that would be the answer to our prayers and heating would stop. But would I be correct that even if we stopped burning a single hydrocarbon molecule for any anthropogenic use listed here below natural releases might still or probably would be accelerating for quite some time based on what we've already done?
Of course they would. There's no stopping it at this point.
So how can it be that people fantasize that if just everything went electric, EV, zero emission from the tailpipe, that heating would stop? It chemically and physically and biologically would continue. We don't know for how long. It's such an impact that we've made. Is that correct?
Yes, absolutely. And the more we emit, the longer it will take to come down to a reasonable level. So if we emit only, say, 1 liter of gasoline, only that much amount of carbon is released into the atmosphere. That will have essentially no effect within 10 or 15 years. But if we emit 1,000 times that amount, that lag will persist for a lot longer. The ability for us to rein that back in, it just doesn't exist anymore. And so we're at the point now where we have emitted so much carbon and so many other greenhouse gases. There's no stopping this show.
It's got momentum. It's got biochemical and biophysical momentum.
That's the word I was looking for.
Right. This is from Inside Climate News. So here's another graph which shows that natural resources, wildfires. Now, right there's a tipping point. That wildfires have increased dramatically in scale, scope, intensity, and frequency in area by every measure in the last 50 years. And so they are a source of methane. The oil and gas sector, other industry and waste. Agricultural burning, surprisingly, it's on this chart is given a very small slice here. Let's just read here. Methane is the most prominent greenhouse gas next to carbon dioxide, is far less prevalent than CO2, but in the short term, it packs a bigger punch. Methane stays in the atmosphere for about 9 years. That's long enough to become mixed throughout the atmosphere. So what's emitted in Texas impacts the Arctic and vice versa, but short enough that cutting back methane emissions could have a near-term impact. So it's not a forever chemical. And this last sentence says, if we cut back, well, whatever we don't release this year isn't going to stick around for 9 years, but there's still 8 years of what we submitted, it released in the atmosphere from last. And you and I know that 8 years of methane is causing heating that and tipping effects in the natural releases and wildfires and so forth that's going to worsen. But let's put that aside. In the comparatively brief time that methane is in the atmosphere, it warms the planet about 86 times as much as the same amount of CO2, according to the IPCC. Methane levels have doubled since the pre-industrial era, trapping more heat in the atmosphere and re-radiating back to Earth. In the Arctic, meaning that methane release, melts sea ice, thaws permafrost, and disrupts global weather patterns. Roughly 2/3 of methane comes from man-made sources, oil and gas, agriculture, and landfills. And in agriculture, it's compost, manure pits, cow belches, and probably dozens of other specific things we do. Methane also has natural sources like wetlands and thawing permafrost. As global methane levels have increased, the impact has been felt twice as much in the Arctic, about 0.5 degree Celsius more of Arctic warming, according to climate models. It is quite a potent greenhouse gas. We don't hear about it nearly as much as CO2.
Right. And its potency, people are quick to point out that the potency declines in a relatively short period of time. But that's only if we stop emitting methane. If we keep emitting methane, and there's no indication we're going to go any other direction, if we keep emitting methane, then the potency does not decline over time. It increases because we're generating more and more methane all the time.
Indeed. And we remember this slide, all the uses that we have for what comes out of a barrel of oil. And I'm also struck by the fact that if we do reduce gasoline for internal combustion engine cars, we're still going to need and going to be taking for foreseeable future almost all of these other uses out of a barrel of oil. And I think we might be faced with the same question that Edwin Drake was faced when they first began using oil just for kerosene, is they threw away and wasted and literally just left in the atmosphere all the other fractions of the oil they extracted in Pennsylvania, other than diesel oil and a few waxes and lubricants. Gasoline was simply evaporated and taken out. And if we stop using gasoline, if the fantasy is that we're going to completely eliminate gasoline and we will move to electric generation for most cars, what will we do with the gasoline? There's no fixing it. I mean, a barrel of oil, it is the largest fraction that comes out of almost all oil is gasoline. It's a larger fraction usually than diesel. There's some oils that produce more bunker oil and diesel than other oils, but some gasoline's always going to be there. What will we do with it, Guy? Do you think it'll go unused? Let me ask another question. Do you think it will go unused?
Only if we completely change this set of living arrangements. And I don't think most people are willing to do that. And let's think about the justice of doing that. A lot of people depend upon this set of living arrangements for their continued survival, like nearly 8.5 billion people at this point. We can't just suddenly stop producing greenhouse gas emitting carbon sources and expect people to go back to what? Growing a garden in their own backyard? No, most people don't have that kind of property to do that, and they don't have the knowledge anyway. Even if we could suddenly transform the society into an agricultural one, and everybody suddenly was able to produce enough food to feed themselves, you think people would find that to be a perfect set of living arrangements? I don't think so. We have become adapted as individuals, as communities, as a society to accessing certain materials that we would no longer have access to. That'll be really inconvenient, to say the least.
And it's actually impressive when you think of, I have friends who hunt in a very ethical way. I mean, they use the entire animal. They talk about using it nose to tail. And they're very, very scrupulous about this, as I think good hunters are. And they use precisely one round. They use single shot rifles. And they're exceptionally concerned about not wounding the animal they're taking, but killing the animal as quickly and humanely as possible. But they're very concerned about they try and make use of every part of the animal. And what's interesting is the oil industry Since that first oil well in Pennsylvania that only used kerosene, what you'd have to say is that they have made use nose to tail of almost everything that a barrel of crude oil is producing. I mean, I'm not here praising all of these products. I'm just making a point that every uses have been fashioned, and obviously consumer dependencies have been fashioned from biotech, almost all of our medicines, all the molecules, toxic or healthful, that are produced for our health system and our big ag and big pharma. These things are almost merging. They're just a giant organic chemistry factory. Our jet fuel, lubricants, waxes, diesel, bunker oil, asphalt, gasoline. What an effective nose to tail use of a barrel of oil. And if we then stop using gasoline, I mean, one might worry that it's just going to be wasted or flared or somehow despoiled into the environment. I'm pretty sure I'd make a bet. I'd make $100 bet that even if we have a future where gasoline is not used for a passenger vehicle for personal transportation, we will find that gasoline is being used for some other product that we're made to rely on. What do you think, Guy?
Of course. I mean, that 42 gallons in a barrel, that's amazing. The things we get out of those 42 gallons, it's not just maintaining this way of life. It's all the privilege we enjoy. It's survival in many cases. The ability to extract lubricants, waxes. It's not just about jet fuel and transporting people. It's about transporting food. It's about transporting everything we've come to depend upon for our continued existence. This is a big deal.
And I think also we can say that it helps defray as oil becomes and gas becomes harder to get. They better get more of these products out of it to defray the cost of getting it. I mean, it's not that I want it to happen. That's what they must do to keep getting all these other things. Even if tomorrow gasoline goes away, they're going to have to find something to do with that gasoline that makes some money to keep affording to pull these barrels of oil out of the ground. That would be my point. And they're not going to stop. I mean, I would make $100 bet.
Pharmaceutical companies by themselves justify extracting all that oil.
Indeed. Nobody's going to want to do without medicines.
Right.
Yeah. Or the increasing loads of plastic that we have to use to administrate in medical, personal protective equipment, disposable medical goods. It is just a mountain that continues to grow ever since this pandemic, and it will only grow further. And so here is just some pictures of what the oil extraction industry looks like. And in each case, there is methane being flared that you can see. Those are not very efficient. The burning of a flare does not combust nearly all the methane. It is just one thing that is done with methane. There's methane that is knowingly released that is not flared, and there's vast quantities of methane that are released that nobody can measure. This is another chart. I'm going to go more rapidly here. Global methane emissions from the energy sector. And so the light blue is oil, the dark blue is the mining of natural gas, the green is coal, and the dark green is bioenergy, and that's from IEA 2023. Coal mines produce methane emission. So and this is all in the millions of tons of methane. The methane directly from the coal mines, from drainage, from ventilation and remaining emissions. You know, sources here by color, whether it's from thermal coal used for heating or coking, which is used for steel and iron making, flared oxidation recovery. I mean, you can drill into this if your curiosity is where the heck is the methane situation. Please drill into it. I'm only, even with this data, skipping stones over the top. World methane emissions from energy sources, IEA estimates. So here we have onshore oil. steam coal, onshore gas, offshore oil, coking coal. And then at the bottom, we have the little designation, all fugitive. That means, I guess, we don't know, we can't control it. We didn't know where it went. Vented, we know what that is. That can be measured. Flared, we know that we're doing that. They have to put an igniter, by the way, at the top of a stack to flare it. It's not just, you don't just light a match. It has to be, to be at all, to at all guarantee a decent level of combustion, of flaring, you need a system at the top that ignites it and multiple igniters that try and assure that it's all burned evenly. I mean, we have to put the time and money into actually trying not to just release naked methane into the atmosphere. And flaring it is requires time, money, and monitoring by these industries. Thoughts, Guy?
Methane is huge, and most people don't know much about it, if anything. And these little tidbits of data that we're skimming over indicate how important it is. In addition, everything we hear about methane is probably underestimated pretty significantly. For example, that it breaks down in a certain period of time. It almost certainly takes longer than we frequently hear. 9 years, 12 years, 86 years, whatever. A certain amount of methane from the huge amount of methane that we are emitting, a certain amount of that is going to remain for a very long time, contrary to what you often hear. So again, my phrase that people have, I'm sure, become tired of by now, it's worse than we are able to indicate.
I totally agree, Guy. And you have to start looking at this data based on your knowledge. So I'm just going to use this chart as an example for where you have to, even a climate scientist, you just know the following. What percentage of North American agriculture is now, follow me on this, the growing of dent corn, field corn hybrids that are solely grown and designed to become ethanol fuel? I think it's 30% of North American corn. I invite people to look it up and tell me it's only 20, or it might be 35%, but I think it's around 28 or 30% of all corn that is planted in North America using our agricultural fields and resources and our land is just for fuel. And so here's a chart from IEA that I'm pretty sure, I bet another $100, another Benjamin, that this chart is not adjusted for that. In other words, the agriculture here saying that methane is 40% world methane from agriculture. It is not adjusting for that part of agriculture that is growing biofuels, which are actually grown for energy. And the energy sector here, as I think Guy has correctly observed, the energy sector, all those estimates, which the energy industry is largely self-monitoring, how much are we emitting of methane from our activities of mining, fracking, drilling, flaring? The estimate by IEA is that it's 37%, slightly less than agriculture. But again, that doesn't include the fact that 30% of all North American corn is grown, and corn grown in other countries too, other grains, is grown for ethanol. Thoughts, Guy?
Yes, absolutely. You know, these charts with only 4 bits of information on them: agriculture, energy, waste, other. They're very coarse categories that things are put into. So there are limitations there, obviously. And there's some overlap between these as well. As you pointed out, dent corn or field corn is grown for energy. So how much of that agriculture, how much of that 40% actually belongs in that 37% energy? Is that 10%? Is that 20%? That makes the energy source, the energy bar, longer than the agriculture bar, and
Indeed.
so on.
Indeed. And, you know, I get this, I hear this from my vegan They're not friends, but they're just the vegans. You can't avoid them. And they will say, oh, agriculture is the biggest emitter of methane. And within agriculture, animals are the biggest contributor of methane within agriculture. And you're like, well, you know, you don't know where to start. Yeah, you don't know where to start. We will drill down into agriculture and animal emissions across the board in a future thing. There's no point in doing it here. We only have a few minutes left. This is a chart just of US reported methane emissions and the top emitters. Just one storage facility in Mississippi, the Petal Gas Storage Station, is responsible in 2020 for 123 metric tons of CO2 equivalent. And this is, again, just the top emitters that are reported. I'm going to move along more quickly here. We do have, it's coming online. I don't think it's fully online, but there's more than one satellite. The Europeans have one, and the Americans have one that measures methane. It can measure single point emissions, and here, for example, is methane emissions coming from the blowout of the North Stream pipeline that can be visible bubbling at the surface. So we are increasingly able to see methane from significant releases by the industry. And this is a global map. Again, IEA. It's a map at the IEA. You can trace it out. It shows global data from satellite observation of methane emissions. Obviously, the largest ones are visible, but the regions, these are the oil patches of the world. You know, you can see the British offshore oil region at sea. It's not even over land. You can just look at this arrow here. There's Britain, and that's the middle of the North Sea. Look at that quantity of methane. You can see, of course, the Middle East is one gigantic methane release, the Gulf oil. You can see North Africa, the Caribbean, the methane releases in the oil sands of Canada and in the Bakken Shale of the US, this region up here in the Dakotas. And so are these going to be capped? Are our movements? The industry is trying to clean itself up because guess what? It's much more visible now, flared or unflared from space. Thoughts?
Yes, I mean, people have been calling for the oil and gas industry to get cleaned up for a long time. And look at that huge dot near Houston. Galveston area is still cranking away. I mean, it's in competition with the Middle East and Northern Africa. So are we going to clean ourselves up? I suspect only when we have to, only when it's forced upon us. Maybe then.
But Guy, is your stove gas or electric?
Yes.
Which one? Both?
We have one of each, in fact.
Guy, you're killing the planet.
Yes, I know. I hear that every day, Neil. That I am solely responsible for killing the planet. Yes, I know. It used to cause me great concern, but I'm pretty much over that by now.
But I mean, you're the people who you and I know who are regularly lecturing us. Why haven't you, if you cared about the climate, you would take your perfectly good, safe, properly hooked up, not leaking gas stove and unhook it and ditch it by the curb. And you would go out and buy, and they cost $1,200, a cook stove with induction top, and you need an oven, so it's going to have an oven. And guess what? That oven is not induction. It's just a normal electric oven.
Right.
But you're going to have to replace that and most of your cookware, which will cost $1,200. And your cookware is going to go out there on top of the stove to Goodwill. And I promise you that a Central American family is going to screech their gas-powered pickup truck to a stop. And they are going to load your stove and that cookware into the back of their gas-powered pickup truck and say, God bless America. Thank God. Look at this, a gas stove. And they're going to put that gas stove into use within hours of you unhooking it. But be that aside, you need to feel guilty for the natural gas that you're using, the tiny fraction of natural gas that you might use to boil an egg or to rewarm that soup that you made. You are made to feel guilty that small amount of natural gas, which is almost fully combusted and used, and is not leaking otherwise. Because if it were leaking, you'd smell it, and the gas company would come and fix it. No. The industry is, each hour that we're talking, is releasing far more gas than all the North Americans use in cooking their burritos. I will one day have that data. I am researching that data so that I can actually prove it. But on a conjecture basis, just look at the amount of methane that's being blown off with no combustion, no use, just waste.
And let's not forget, folks, that according to 5 peer-reviewed papers by Tim Garrett at the University of Utah, civilization is a heat engine.
You bet it is.
Doesn't matter
Everything
how
we do.
power. Yes, exactly.
So the Canadians lately have been more honest, and they have used the satellite data and other data to admit that their releases are at least 60 to 70% more than what the voluntary reporting is. And so here we see a chart that goes to gas leaks, the leaking of methane in Mexico, US, and Canada. The white is reported, the red is measured and estimated. So it's at least, I don't know, I can't do visual math, but it looks like it's at least 30 or 35% more is actually being emitted than is reported. And surprise, as Gomer Pyle would say, surprise, surprise, surprise. This is 2 charts side by side. They're pretty much the same data. Agriculture here in the right, this is labeling 93 million tons, metric ton equivalent as related to animal methane of the agriculture. It is looking like it's a majority of what they're measuring for agriculture. And this is satellite measurement of leaking methane. We've got industry, passenger trucks, and other categories here. And then this is a close-up again on the Mexican, American, and Canadian data. This is another place you can go if you want to research this, the globalcarbonatlas.org. And again, it's characterizing metric tons equivalent of CO2 of the carbon emissions across the board. So it's not just methane. And here we have, we're starting to get into these estimates. So I'm going to close with just a rapid go through of all of the things we have to do to go to net zero by 2030. We have to somehow, we've got here on this chart, we've got natural fluxes labeled in green. So natural emissions, wetlands, sinks in soils, and it goes in both directions, of course, naturally. Chemical reactions, the atmosphere, and greenhouse gases carried down into the soils absorbed by trees are sunk. But then when the trees decay and wetlands are a constant cycle of decay, methane is released, and animal wastes and microorganism wastes. So that's natural. Then I'm going from right to left. Then we've got biomass and biofuel burning. And on the left, we have what they're labeling as anthropogenic fluxes, fossil fuel production and use, agriculture, and waste. And we then go to these wonderful charts which show what reductions are needed. And so here we are in 2023. Actually, this is from 2023, so it's about almost a year old. Historical amounts of methane being released in this gray line. And then what are all these pie slices here? Well, this is, if we don't achieve any targeted abatements, they fantasize that it's going to, I don't know why they fantasize it's going to decrease, but I guess they're building that in. Like I don't know what makes them not put this line going straight up to the right, but they are humoring themselves. But then there's all these slices with different scenarios of how much we're going to cut. And then there's how much we have to cut to get to net zero in just, let's see, Guy, 6 years, 2030? Are you going to put a $100 bet? I'm going to put a $100 bet that in 2030, if we're still having this conversation, the methane emissions are going to be above the line here of no targeted abatement. They're going to be significantly above that.
Of course. And the critical phrase there was if we're still able to have this conversation.
Indeed.
Because I think we might get to net zero in 2030.
The hard way.
Exactly. That will not be fun.
It could be. You're right. We could get to net zero because of a nuclear war. We could get to net zero because of a total collapse instigated by any number of sources that we're doing to ourselves, any number of overshoots. But the chance that we're going to get to net zero in a managed way by inducing the fossil fuel industry to unhook its massive emissions of methane into the atmosphere as they dig up all the other shit that we're still depending on. The idea that you're going to get to net zero by people unhooking their gas stove and leaving it to the curb so that the deserving Hondurans and Nicaraguans and Mayans can plug it in as they will within an hour of it being left on the curb. If you think you're going to get to net zero by changing your cookware and your stove, please, people, please.
Not yourself.
As Mr. T would have said, he would have used a different word. Methane emissions from fossil fuel operations in the net zero scenario, Guy, 2000 to 2030. And, this isn't some fantasy chart released by Bill McKibben's organization 350.org back in the brief period where CO2 was below 350. No, this is to be found on the IEA for 2023 or 2024. Look at the slope. This is data. This is obviously from 2022. Excuse me. This chart is a little older than the other ones. In 2022, they published a chart that showed the actual, to what they measure, methane reported from the natural gas, the blue, the oil industry, and the coal industry. And look at this slope, how it already should have gone down. I mean, this was from 2022. It's halfway through 2024, Guy. We should be well down this slope just from this chart. But I guarantee you that this year they're releasing the same chart. They've just moved the slope up.
So mission not accomplished? Is that what you're saying?
Mission not accomplished. Mission is fantasy. Fantasy Island. You can come to Fantasy Island. What's that? That it was the Love Boat, or what was it? It was called Fantasy Island. Some stupid series. No, this is Fantasy Island, 2030.
Yes.
I mean, you've been doing this, and I've known you longer than from now till 2030. Now till 2030 is a mere 6 years, 5.5 years. I've known you for double that time. Do I have a belief? Can I be convinced that even if I did everything that my vegan libtard friends want me to do, I would play a role in bringing us to the points on the line in this chart for 2030? I'm sorry.
It's a tough future ahead of us, and posting fantasy graphs like this one are not helping.
I don't think so. So we find, as we close this episode, I remind people that here is where we are in significant human history. From 6,000 years ago, when we were in the agricultural age, we think, that was powered at that time by human muscle, whether of non-slaves or slave humans or animal slaves. And at around 1600, 1700, coal began to be used at scale, other than firewood. Firewood was sustainable and self-limiting. We indeed deforested most of Europe for firewood, for wood burning, for steel, to use it for everything. Minting coinage. The Romans used too much wood for that, apparently. And we have a carbon pulse in which we are either, depending on what religion you are, we're either still on the upslope going up, or we're already on the downslope. But something like a post-carbon zero emission future is ahead of us. We just don't know how we're going to get there, which of many forces are going to take us there. Thoughts, Guy, as we bring this to a close?
Yes, again, we have a difficult future ahead of us. This post-carbon future that I hear about all the time is either fantasy or meaning it's not going to happen in any way that we recognize the set of living arrangements, or it's going to cause such disaster all along the way that there will be no recording of it. It'll be, as Albert Einstein talked about World War III and World War IV. He said, he indicated that World War III, he didn't know what would cause that and what weapons would be used, but World War IV would be fought with sticks and stones.
I would put $100 Benjamin on that for sure.
And if you're excited to see that world, well, knock yourself out. I'm not.
All right, sir. Well, I think we've gone through a lot today. We're going to go into the other greenhouse gases and emission products besides CO2. Believe me, they will make methane look like a pussycat.
A walk in the park.
A walk in the park. All right, folks, that's enough for today.